What's up, everyone? In this video, we're going to be talking about the area of a sector. So we first have to know what a sector is. A sector is a portion of the area of a circle. So if we go back to an arc, right, an arc was a portion of the circumference, and for a sector, we're now dealing with the area. So imagine taking a slice out of a pizza. So if you take a look at this diagram on the left, usually a pizza is divided into 8 equal pieces, right? So if we take one slice, a sector is going to be the area inside of that slice, right? So when we make a sector, when we slice up our circle, there are going to be major sectors and there are going to be minor sectors. The minor sectors are the smaller portion, right? So in this case, this one slice is the minor sector. But we still have this whole big portion of the circle that's created when we take that slice, and that is going to be our major sector. So we're not going to always have nice images of pizza, so this diagram on the right kind of gives us a nice representation of just a general old circle, where in green we have our minor sector, and then in yellow we have our major sector. So we're going to actually be solving for the area of a sector, and again, it's a fraction of the total area of the circle. So just a refresher, the area of a circle, right? That is this entire shaded region inside. So I always like to relate area of a sector back to eating a pizza. If I eat this whole pizza here, I can figure out how many square inches of pizza I ate if I do pi r squared, right? But let's say one day I wasn't as hungry and I ate this much of the pizza, right? That's going to be a fraction of the entire area. So we got to figure out what portion of the pizza or what portion of the area did I eat. That's all going to depend on our central angle. Now remember, the central angle is just the angle that's created. So let's say we sliced up our pizza and this was one slice. The central angle is that angle that's created right here with the center of the circle, right? So in this case, let's say theta is 180 degrees, right? So that would represent me eating this whole entire portion of the pizza, right? What portion of the area is it? Well, if we do that 180 over 360, we can see that we ate half of the pizza. So if I want to know how much pizza I ate, I have to do 1/2 of whatever the full area is, and that would tell me the area of that sector, or the area of that slice of the pizza. Now let's say another day I was even less hungry, and let's say the slice of pizza that I ate was only this large, right? Again, to figure out how much area of pizza I ate, it all depends on that angle that I create with the center. So let's say that this angle right here is 90. Now we have to figure out the portion of the circle that we ate. So again, if we do that 90 over 360, we'll see that we ate 1/4 of the circle. So I didn't eat the full area. I didn't eat the entire circle. I ate 1/4 of whatever that area is, right? So that's the whole idea of area of a sector. It's very similar to finding arc length, except arc length was just a fraction of our circumference instead of a fraction of our area. So there is a formula for this. So we have that the area of a sector is equal to theta over 360, right? This was the fraction of the circle that we found. And remember that theta is the central angle, right? And we take that fraction and we multiply it by whatever the total area of the circle is. Now the area of a circle, we have a formula for that as well, right? So another way that you can see that formula is that the area of a sector equals theta over 360 times pi r squared. And again, this is just another way to represent the area. All right, let's get right into an example here. So in this first type of example, we're going to be given some information and we're going to substitute it into our formula to find the area of a sector. So let's start by reading and annotating our problem. So in diagram below of circle O, the measure of arc ML is 36 degrees. The radius OL is 4 inches, and it wants us to find the area of the minor sector and the major sector. And it wants us to leave our answers in terms of pi. So a couple of things here. Remember, we have to remember that arc measure is congruent to the central angle. So it's saying that the measure of arc ML, right, and the measure of an arc, remember we put a radii or radius to the center, and the arc measure in this case is 36 degrees, and that's going to be equal to our central angle as well, right? So we're going to do the minor sector first, which is just this smaller shaded region over here. But let's also label that the radius is 4 inches. Now let's make our list of variables that we have here. We have theta is 36. We have that the radius is 4. And we are looking for the area of the sector. So we'll say area of sector equals question mark. So let's go ahead and substitute these in. So area of a sector equals theta, which is 36 over 360 times pi, and then we got 4 squared here. Now again, you can figure out this formula just thinking about it conceptually, right? We know, we always compare it to eating pizza, right? So if I ate this much pizza, I know I didn't eat the full area, which would be pi r squared. I got to figure out the portion of the circle that I ate, and that's where that theta over 360 comes from. So 36 over 360 gives us that fraction of the circle, and then the pi r squared is just the area of the whole thing. So let's simplify this a little bit. So we get area of the sector. If we simplify that fraction, or let's not even do that yet. We get 36 over 360 times pi times 16, right? Now, when it says leave your answer in terms of pi, that means you simplify everything else but pi. So we can go into our calculator, and another way that you guys can get the fraction symbol is if you hit alpha y equals, and then you hit enter. That will give you an option to type your fraction in. So we do 36 over 360, and then we're multiplying that by 16, and that gives us 1.6, but I want it in a fraction. I'm a fraction girly. So we have that the area of our sector equals 8 over 5, and we got to remember to put that pi back in, right? So this is the area of the minor sector. Now we got to find the area of our major sector. So if we're finding the area of our major sector, our angle is going to change because clearly if we eat like 36 out of 360 of the pizza here, we're only eating this small portion. But we're not only eating that small portion anymore. I want to know how much I ate now if I eat all of the rest of this, right? So if we want to know that, we have to figure out what the measure of that angle right there is. Now, we got to use the fact that in total, a circle is 360 degrees. So if we do 360 minus 36, we'll have that larger angle there is 324. So I'll take out the shading here just so we can have a better idea of what's going on. But this bigger angle here is going to be 324 degrees. Our radius is not changing. Nothing else is changing. Just the fact that we're dealing with the major arc now. So now we need to change where our central angle is at, or what our central angle is, right? So we get theta equals 324 now. Our radius is not changing. That's still 4. And again, we are still looking for the area of the sector. So let's go ahead and substitute. We get 324 over 360 now. And then that area is not changing, so I already know that's going to be 16 pi. So now, again, we're leaving our answers in terms of pi, so now we can do alpha y equals, hit enter, and then you do 324 over 360 times 16. Let's get that in a fraction. So we get that the area of our sector is equal to 72 over 5 times pi. And remember, put your units in there. So inches squared, we're dealing with area. So 8 over 5 pi inches squared, 72 over 5 pi inches squared. Okay? Now, the second type of example is they might give us the area of a sector now, and we're going to have to go backwards. So it says in the diagram below of circle O, the area of sector MOL is 2 pi square units, and the length of MO is 6. And it wants us to find the measure of our central angle. So we make our list. Now we know that the area of our sector is 2 pi. We know that MO, which is our radius, is 6. And we're looking for theta now. Now, a big thing about this, too, is that it says it wants it in degrees and radians. So we're going to find degrees first, and then we'll use our conversion chart over here to help us switch that around. So again, let's write this in. The area is 2 pi, and we are looking for this measure here. So let's write our formula out. We have area of a sector equals theta over 360 times pi r squared. So now we know our area is 2 pi. Theta is going to stay as our variable, so we get theta over 360, and then we get pi times 6 squared. So the first thing that I like to do, I see pi on both sides of the equation here, so I already know that that's going to divide out, so I'm going to cross it out now and make my life a little bit easier. So we get 2 now equals theta over 360, and if we simplify this, we'll get 36. So from here, we want to solve for theta, but right now this term, this 36 here, is making it like really hard for us to do that. So let's get rid of that. If we divide by 36 on both sides, it looks really messy on the right, but again, the whole idea is you're doing it so that you can cross it out. So then we're going to have 2 over 36 equals theta over 360, and if this is confusing you, you can change that theta to x. But once you get here, it should look familiar to you. Now you're just going to cross multiply. So if you go here, you get 2 times 360 equals 36 times theta. And then we're going to have to divide by 36 on both sides. So if we do 2 times 360, we get 720. And then we got to divide that by 36. That gives us 20 degrees. So that's it in degrees, but now we want to get it in radians as well. So to go from degrees to radians, we need to multiply our angle by pi over 180. So we do 20. So now we got to go from degrees to radians. So we do 20 times pi over 180. Now, it's 20 over 1, right? So sometimes it helps to see it like this because you can just multiply straight across. So we get 20 pi over 180. And then we need to simplify that fraction of 20 over 180. So we do 20 divided by 180. You hit enter, and then you hit the math button, and you hit enter on fraction, and enter again, and you get 1 over 9. So it's going to be 1 over 9 pi, or pi over 9. So that would be it in radians, and this would be the central angle in degrees. So don't forget, you can conceptualize this. Again, the area of your sector is simply just a portion of the area. So figure out the fraction of the circle that we are eating, and then just multiply it by the entire area of your circle.